Thank you so much for being with me on this Collab College Algebra video series. We are now on 2.5 Exponential and Log Equations. Before we get started, let's go ahead and review a few things with logs. Um, First, let's do a warm-up. Let's do some warm-up to review. Okay, so what if we have log 327, and I want you to rewrite this as exponents. Okay, so log 327, to rewrite it as an exponent, you would write 3 equals x. 3 to the x equals 27. Okay, so that's the circle of life. 3 to the x equals 27. Number 1. Okay, let's do another one. Log 9 of 1 over 9 equals -1. We write it as an exponent, circle of life. 9 to the 1, -1 equals 1 over 9. So circle of life, 9 to the -1 equals 1 over 9. And that's a true statement. 9 to the -1 is indeed 1 over 9. Okay? So let's also practice condensing. So condense the following. Condense the following. Number 3. Let's say you have log base 10 of 3 plus log base 10 of x. To condense it, remember addition becomes multiplication. So this is log base 10 of 3x. And remember, base 10, we don't really need to write it. So if you saw log of 3x, that's the same thing as knowing that this is log base 10. Okay? So that's that. Hopefully I got you warmed up. Now let's ask this question. We didn't do specific practice on it, but we're gonna do a lot of examples on it at the end when we review this whole unit. So let's say number 4. This is a question for you. What is log base 4 of 16? What would the answer be? What if you had log base 4 of 16? What do you think the answer would be? Okay, so think 4 to the what power gives you 16? So log is, for the base, think 4 to the what power gives you 16? Okay, well, 4 times 4 is 16, so 4 squared, 4 to the second power is 16. So the answer is 2. Okay, how about another one? Log of 1, let's say log of 1000. Okay, so now you have to think to yourself, what is the base here? They don't give you a base, so what is the base? Remember, if you don't have a base, that's an understood 10. Okay, so that's an understood log base 10. So 10 to the what power is 1000. 10 times 10 is 100. 10 times 10 times 10 is 1000. So 10 times 10 times 10, that's 3. So 10 to the third power gives you 1000. 10 to the third power gives you 1000. Okay, I hope that warmed you up. Now we are going to work with log equations. Okay, now remember what we've been doing, what we did on the warm-up are mostly expressions. Equations have equal signs. Okay, so you know something is an equation because you see an equal sign and you're like, okay, that's an equation. Okay, and these are all equations, they're equal sign, and the problem is asking you to solve for your variable. Okay, so you're solving for your variable, so you are solving equation, and you look at this, these are equations with logs, therefore these are log equations. Okay, so now that we figured that out, now we want to go ahead and solve these things. So, first one, number 3. We're starting at number 3. Log 8 base 8 of 3k plus 7 is equal to log base 8 of 4k minus 6. So when you have log equations, what you want to do is try as much as you can to drop the logs. Okay? Try as much as you can to drop the logs so that you have an equation that you're used to solving. So if you see log on both sides, what you want to do first is make sure that all the sides are condensed. Okay, so condense all sides. Okay, so the left side, again, the equal to separates the side. The left side, you look at it, it's already condensed because it only has one log. The right side, you look at it and it's already condensed because it only has one log. Okay, so if you see log on both sides, the first thing you want to do is to condense it as much as possible, make it into one log. Step 2. Okay, step 2. If you have the same logs on both sides, then that's good. You should be like, yay, this is an easy problem. So notice how I have log 8 here and log 8 here. That's excellent. If you have the same logs on both sides, you can cross it out. Okay? If you have the same logs on both sides, you can cross it out. Okay? So I will tell you the reason, but I think it will complicate things. So let's just stay with, if you have the logs on both sides, you just cross it out. Okay? Now, once you cross it out, you just have 3k plus 7 is equal to 4k plus 6. See, now once you've taken out the logs, this is what you've done before. You have an equation, a linear equation with variable on both sides. So what you want to do is get all the variable on one side, get all the constants on another side. So I'm going to get rid of this 4k by subtracting it. So I want to get rid of it completely from the right side. So I'm going to try to make it 0 by subtracting it, doing the inverse operation. This crosses out and becomes 0. This gives you negative k plus 7 is equal to negative 6. Now I want to get all the numbers on the right side. So I will subtract 7 on both sides. Okay, so that negative k is equal to negative 13. Now go ahead, you have negative k, just divide by negative 1 on both sides so that your variable k is equal to 13. And that is my answer. Okay, and then once you do that, you want to go ahead and plug in your answer to make sure that it makes sense. Okay, so we're going to do a verbal check. 3 times 13 is 39. 39 plus 7 is 46. Log 8 of 46, is that equal to 4 times 13? I need to do that with my calculator. I could also show the work, but since we can use a calculator on this test, let's go ahead and practice using our calculator. So this is 4 times 13 minus 6 is equal to 46. So both sides equal 46. This is good. Okay? You also want to check to make sure that you don't have the log of a negative number. Okay? Log of a negative number is undefined mathematically, so you do not want to get something where the log becomes a negative number. Okay, so that would be a problem if you did. Alright, so let's move on to the next one. Moving on. Okay, so here we are moving on to the next problem. Notice how you have log of both on both sides. Okay, so if you have log on both sides, make sure it is condensed on each side. So here, notice that on the left side, So equal to divides the sides. So when I'm talking about the sides, I'm talking about on the left of the equal to sign and on the right of the equal to sign. All right. And as we can see on the left of the equal to sign, they're not condensed. They're expanded. You have two separate logs on the left. So the first thing you want to do is condense. That's why we did this as a warm-up to get us ready for this. All right. You have a plus. When you condense, pluses becomes multiplication. So remember, condensing makes it into one log. So this is log 5. This now becomes multiplication. X squared plus 2 equals log base 5 of 77. Now you are condensed. Now the next thing we want to do is notice how it's the same exact log. Log 5 of both sides. You can now cross that out because they're on both sides. So you can do the same operation, cross it out. And now you have 7x squared plus 2 equals 77. Okay, I see a quadratic equation because this is an x squared. A linear would just have an x. Okay, linear, just an x will be the highest exponent or a variable. And quadratic is the variable squared. Okay, so some of you might divide both sides by 7, and that would be perfectly fine. But I think most of you would distribute the 7, so that's what I'm gonna do. Just because I believe a lot of people will just go to the distributive property. 7x squared plus 14 is equal to 77. Okay, 7x squared plus 14 is equal to 77. Okay, since this is a quadratic, there's many ways you can do this. We can go ahead and try to see what's going on. Let's get all the numbers, since there's only two terms. Let's go ahead and get all the numbers on the right side. So subtract 14 on both sides, just to see what this is trying to do here. Okay, what is this trying to do? 7x squared is equal to, this is 3, this is 6. It's equal to 63. Okay? Let's go ahead and get the x squared by itself. Divide both sides by 7. So x squared is equal to 9. Well, if x squared is equal to 9, we kind of want to know what x is. Since this is a perfect square, why don't we just get the square root? We are introducing a square root. Whenever you introduce a square root, you have to add a plus or a minus, okay? Because two things will give you 9 when you square it. A 3 times 3 will give you 9 when you square it. A negative 3 times a negative 3 will give you 9 when you square it. So the answer is two things. The answer is plus or minus 3. So two answers. A plus 3 and a minus 3 will work for this problem. But now, every time you get your answer, you have to plug it in to make sure it makes sense. Okay? So the thing that we really want to pay attention to is we do not want the log of a negative number because that's mathematically undefined. Okay, so notice if I plug in a 3, that would be okay. 3 squared is 9 plus 2 is 11. That's perfectly okay. But if I were to plug in a negative 3, that would also be okay. Negative 3 squared is 9 plus 2 is 11. So both answers are going to work. So the answer is plus x equals plus 3, x equals minus 3. So you can write it out like this. Or you can just leave it as plus or minus 3. They are essentially saying the same. So it's really good to check to make sure that you don't have a negative inside a log. Now we're going to go ahead and move on to exponential equations. Okay, exponential equations are equations, of course, so they have equal signs. And they look something like this. They look something like this. So if I have, so exponential equations look something like this. 2 to the x equals 32. Okay, so it's asking you 2 to the what power will give you 32. Okay, so that's something that you want to figure out. Okay, let's look at some rules of exponents to begin with, just to warm us up. Remember, if you have same base and you're multiplying, you can essentially condense it by adding the exponent. So this will be 6 to the x plus y. Just like if you had 2 times 2 squared, that's saying 2 cubed. Okay, 2 cubed, which would be 8. Okay, same thing if you're dividing. Let's say you have x squared divided by x. You subtract, so this would be x to the 1, or just x. Okay, or if you had x cubed over x to the 5th, remember the trick that I taught you? Subtract and keep it with the largest exponent. So this would be 1 over x squared. Okay, so well, if you subtract it like this, x to the negative 2, that's fine. That would also be 1 over x squared. Alright, so now what we want to do is we want to solve equations like where your variable is an exponent, and we want to figure out how to do stuff like that. Okay, and that is the question. So just like logs, your point is what you want to do is you want to get the same base for the exponent. Remember what the base is? This represents the 6, represents the base here. Okay, so you want the same base. And if you have the same base on both sides, you go ahead and drop the bases, and then you just work with the exponents like equations. So these two have the same base, so you just have negative x equals 2x. Okay, let's get all the x's on one side. So 3x equals 0. So your variable x must be 0. Okay, and we can quickly check it. 6 to the negative 0, is that really equal to 6 to the 2 times 0? Well, 6 to the negative 0 is 0, 2 times 0 is 0. Anything to the 0, these two are the same, or you can say, well, 1 equals 1. So let's do 20 right now. Let's go ahead and do this number that we don't know what the number is. Okay, 1 over 6 equals 36. Here we want to get the same exact base. What can we do to get the same exact base? Well, they have 6's in them, so you can think, okay, well, I can make this to be a 6, right? Because 6 squared is 36. Okay, and that gets you closer to what you want, because now they have similar base. One is 1/6, and the other is 6 squared. The next thing you can do is you can make this 6. Okay, 1/6. You know that a negative changes position, so this could be 6 to the negative 1 equals 6 to the negative 1, you have to write all the other chunk that comes with it. Okay, so this is 6 to the negative 1. Copy down the rest of the stuff that comes with it. 3p squared minus 2 equals 6 squared. Okay, so now we have the same base. All you need to do now is just simplify. So 6 to the negative 1, but then it has all these extra exponents. Remember, a power, this is a power raised to a power, you multiply. So multiplication, you have two things. So you're going to be using the distributive property, just like that. So this is 6 to the 3p squared plus 2 equals 6 squared. Okay? So now you have the same bases. You can now cross them out. and this is 3p squared plus 2 equals 2. Subtract 2 on both sides. 3p squared equals 0. Okay, divide by 3, so your p squared equals 0 because you divided by 3. And then square root of 0 is plus or minus 0, which is just 0. So your p is just 0. Okay, and if you plug it in, okay, if you plug it in, this on this side, you have nothing to plug in, so you care about this side. So 1 over 6, 3 times 0, because our p is 0, negative 3 times 0 is 0 minus 2. So 1 over 6 to the negative 2 is the same thing as flipping the positions. So to get rid of that negative, this is just 6 squared, which is 36, and that's what we want, so our answer is correct. Okay, so again, what you want to do, first you get the same bases, do whatever you can to get the same bases, and then drop the bases and solve the equation, whatever kind of equation you have. So let's do 20. Okay, 20. I'm kind of tired of zeros. Let's skip 20. Because I can already see that the answer is going to be 0. So I will replace that problem with something a little more exciting than just getting a 0. Okay, so let's do 21. 16 and 64. I don't care that the 64 is in the denominator because I already know how to make that what I want. So let's go ahead and make that what I want. But before I do that, let's try to get them to be common bases. 64 and 16. Well, I know that 4 times 4 is 16, and I know that 4 times 4 times 4 is 64. So I can make them to have base of 4. Okay, so 64 is 4 cubed. 4 times 4 times 4. Keep the m. Equals 16 is 4 squared. 4 squared, and keep all the other stuff that came with it. 3m minus 2. Now, I want them to be in the same position. So 4 cubed, let's just change that to 4 to the negative 3. Okay, 4 to the negative 3 is the same thing as 1 over 4 cubed. So if you change the position, all that does is changes the sign of your exponents. So here I'm just going to go ahead and distribute and simplify that. So power squared to a power, you multiply. So this multiply, and since it's two things, you're just going to have to use the distributive property to address both issues. So 4 to the negative 3m is negative 6m. 4 to the negative 2 times negative 2 is negative 4. Okay, here I'm also going to do the same thing, power to a power multiply. So this is 4 to the negative 3m equals 4 to the negative 6m minus 4. Okay, so now we have the same base, we can cross out, and we have negative 3m is equal to negative 3m is equal to negative 6m minus 4. Okay, so I want to get all the variables on one side, so I'm going to add 6m to both sides. So your 3m, negative 3 plus 6 is 3m. This goes away, equals negative 4, so my variable m is equal to negative 4 thirds. Negative 4 thirds. Okay, so I'm done. Alright, and you can always go back and check it, and I'm gonna let you go ahead and enjoy and do that on your own. Okay, let's find another one since we kind of got rid of one problem. Let's find another exciting problem here that we could do. That's not going to give us a negative, a 0. Okay, let's do 17. That looks fun. Okay, 17 looks fun. Awesome. Okay, let's go ahead and get it here. Alrighty. So you have exponential equation. So whenever you see exponential equation, you need to think, okay, how can I get both to have the same base? Students get really confused here because they see 1 and they're thinking to themselves, how can you get 1 to be 6? But that is actually one of the easiest questions you have, because you can make 1 anything you want, because anything to the 0 power is 1. Anything to the 0 power is 1. That's a rule that you should remember. That's a rule that if anybody wakes you up from sleep and says, what's 5 million to the 0 power, you should be able to say 1. Okay? If you're having a bad day, somebody can tell you something to the 0 power and you should automatically grin because you know what that is. Alright, so now we have the same base. Cross out the base and this just becomes 1 minus 2k equals 0. Subtract 1 on both sides. Negative 2k is equal to negative 1. Divide both sides by negative 2. So k is equal to 1/2. Okay? And you can always check it. Okay? Excellent. So that's that. Now, there are another type of problem that I would like to. Okay, so there are a few more problems that I would like for us to address. This one says solve each equation, and it wants us to round to the nearest. You probably want to see this 10/100. Actually, let's round that 2 decimal places. That's fine. Okay, let's say 2 decimal places. All right. Okay, I'm going to need a scientific calculator, so here's my scientific calculator for these problems. Okay, let's see what's going on. It looks like we have exponential equations, but notice how you have something times the number with the exponent. So it's almost like, pretend that this whole thing is your x. Pretend that this is the king, and you want to get rid of all the things that are keeping it from being by itself. Negative 8 is keeping it from being by itself, and it's being multiplied to it. So I will go ahead and divide both sides by negative 8. Okay, so again, this time you want to isolate. If you can isolate, isolate. Okay, this goes away, and you have 15 to the negative 3n equals 2. Okay, now this is weird because normally you want to get the same base, 15 and 2, but there's no way 15 and 2 it's gonna be, unless you know in your head some decimal value exponent to make 15, to break 15 down to 2 to the something power. It's kind of difficult to be able to do that. So what you want to do is, now you want to use the rule of expanding exponents. Okay, so to expand exponents, what you do is you bring this and make it a coefficient. So what you're going to do is you can use the log, or you can use the natural log of both sides. Okay, so I'm going to go ahead and use the natural log, or log of both sides. Okay, so we use log base 10, or we use natural log. Okay, so I'm gonna go ahead, and since we're used to logs, let's go ahead and use log. So log 15 of negative 3n is equal to log of 2. We're gonna go ahead and make this, use the log rules and make this a coefficient. So this is negative 3n log 15 equals log 2. Remember, calculator has log, the log that you calculate has, you don't need to write the base because it's just log of base 10. Okay, so now check this out. Log of 15 is a number. Okay, log of 15 is a number that you can just plug into your calculator. So right now our goal is to get this n by itself. Okay, so let's get rid of log of 15. It's being multiplied to 3n, so you divide both sides by log of 15. And this goes away, so you have negative 3n equals log 2 over log 15. Now divide both sides by negative 3 so you can get n by itself. Okay, divide both sides by negative 3, so that means it's going to go here on the bottom. So n is equal to whatever that is when you plug it into the calculator. So sometimes you can leave this as your answer, and this is perfectly fine answer. Okay, or sometimes they require you to actually get the decimal answer, and that's what they did for this problem. So now I can go to my calculator. Okay, I go to my calculator, I type in log 2. Okay, I'm just going to round to 2 decimal places. Log 2 divided by, I'm going to put parentheses so everything goes in, negative 3 log 15. Again, your calculator doesn't just writes log because it's assumed that it's a base 10. And the answer is negative, since I said 2 decimal places, let's just go with 2 decimal places. And the answer is negative 0.08, 0.09, negative 0.09. So this is a horrible amount of rounding, but we'll take it. Okay, so this is a good answer. Now let's say you just use natural log, ln. Okay, if you use natural log, that's fine. You will still get the same answer. Okay, so ln 2 divided by negative 3. I need to put a parentheses. Let's make sure. Negative ln 2 divided by negative 3 log ln. Has to be, you gotta be consistent. So if you're gonna use ln, you're gonna use ln. Ln 15, and that will give you the same answer. Okay, so it's up to you which one you use. You're just gonna need to be consistent. Okay, so let's go ahead and do the next one, number 24. Again, if you can isolate, you isolate. So 17x plus 8 minus 4 equals 4. Isolate, add 4 to both sides. So 17x plus 8 is equal to 8. Again, it was going to be very difficult to figure out how to make this the same basis. So your idea now is to introduce log or natural log. This time I'm just going to use natural log to show you that you can switch up. You can do what you want. ln on both sides. Okay, now use the log equation, log properties. Exponents become coefficients, so this is x plus 8. They are together. I'm going to put this as together. Ln 17 equals ln 8. Ln 17 is just a number. You can divide both sides by it, okay, because this is your variable. This is your king. You want to do whatever you can to get your king by itself. Ln 17 on both sides, that's just a number. You can divide a number on both sides. Okay, we keep it together, that way it doesn't get messy with all the decimals. But if you are one that just doesn't want to work with that ln 17 and you're not convinced that it's a number, you can just go in and find what ln17 is. Go in, find what ln17 is, plug it into your equation, and that gets rid of your ln's, okay? But sometimes you might need the exact value, so this would be a way to get the exact value without getting a decimal. Okay, so here we have x plus 8 is equal to ln 8 over natural log of 17. I keep saying that ln 8 and ln 17, those are numbers. Now we just want to get x by itself. Plus 8 is keeping x from being by itself, so we're going to subtract 8 on both sides. Subtract 8, so your variable x is equal to ln 8 over ln 17 minus 8. Okay, so we go to our lovely calculators because we cannot crunch these numbers in our head. So figure out what ln 8 divided by ln 17 is, and whatever that is, okay, 0.73, you subtract 0.73 minus 8, and that gives you negative. So your variable, I'm just going to continue, negative 7.27. So x equals negative 7.27. That is my final answer. Okay, lovely, lovely. All right. I know we've done a lot on this section, but this section does require us to do a lot. I hope that you are still with me, and I hope that you can feel free to take breaks. Take breaks, go get some water, calm your mind, and come back and refocus on this. This is a section that requires a lot of work, and that's why the video is long. It's almost 37 minutes already. Okay, so we're back to log equations. Let's go ahead and do this type of log equations. You have logs on each side. You want to make sure that you condense. If you need to, try to condense. Okay, so these two separated by addition, when you condense it, remember when you don't have a base, that's a base 10. That's an assumption that it's a base 10. That's just what we agreed mathematically. Okay, plus becomes multiplication. So this is 5x times 8 equals 3. I'm going to simplify that. So this is log base 10 of 40x equals 3. Again, where did I get the 10? If you have a log and you don't have a base, the assumption is that is a base 10. Just like if you have an ln, the assumption is that it's natural log, so the base is e. Okay, so now you don't have logs of both sides. So if you don't have logs of both sides, your trick here is to change this to exponent. Do the circle of life. Okay, do the circle of life and change this to an exponent. Circle of life. 10 to the third power equals 4x. Okay, 10 to the third power equals 40x. Okay, 10 to the third power equals 40x. All right. So, okay, well, let's make 10 to the third power. We know that's 10 times 10 times 10, which is 1,000, equals 40x. Okay, so now we just want to get x by itself, so divide both sides by 40. Divide both sides by 40. Well, since we already have our calculators, and you can use the calculator, you can do that, or you can do it in your head. This is just depends on where you are. 1,000 divided by 40, 1,000 divided by 40 equals 25. So your variable x equals 25. Okay? And you can do the most basic check to make sure that this is not a negative if you plug it in. positive number. If you plugged it in, 5 times a positive number will be positive. So our basic error check shows us that this is fine. Okay. Now, second one, step 1, condense. ln subtraction becomes division equals 4. ln is our special one that I am actually going to talk about before we do this. ln has a base e. This is the natural log. Natural logs always have a base e. E's undo natural log. Okay, so this is ln. So let's say that it's base e. Okay, so this is log base e of 4x over 7 equals 4. Now change it by doing circle of life. Okay, circle of life, e of 4, and this chunk of stuff. So circle of life, change it to an exponent. E to the 4 equals 4x over 7. Okay, we want to get x by itself. This is our king. The x is the king. The king does not like to be disturbed. The king wants to be by itself. Okay, so first we get rid of the, you can do this 2 ways. Let's get rid of 4 over 7. We can multiply by the reciprocal, which is essentially dividing on both sides, 7 over 4, because 7 crosses each other out, 4 cross each other out. So your x is equal to 7 over 4 e to the 4th. And I believe this question wants the exact value, so this will be an exact value. If it did not want exact value, you can use the calculator, because 7 over 4 e to the 4 is a number, since e to the 4 is a number. Okay, so if we were to use our calculator and you don't want an exact value, that's fine. So you can do 7 over 4 e to the 4th, and that is actually a decimal, 95.546762. Alrighty, that was fun. That was a lot, but it was a lot of fun. I hope you learned something. This might be one of those videos where you have to go back and just watch it over and over again. As you're doing your practice problems, you can watch it over and over again to try to figure out how to do it. Thank you so much for being with me.